The class. Today we are going to discuss about introduction to modern symmetric key ciphers. See, before entering into the exact session of modern symmetric key ciphers, we should understand how many cipher types are there, right? So as we have discussed in the prior sessions about the traditional ciphers, there are two types. What are those are? Substitution and the transposition. See, substitution is nothing but we are replacing the content. Transposition is nothing but we are rearranging the content. Okay, so rearranging can be done with the permutations. Now, we have another type of cipher as a traditional, like which is extension of the traditional, is nothing but the product cipher, right? So product cipher is a combination of both substitution and transposition, as we have discussed in the previous sessions. Now, as we are entering into the standardized algorithms, we are about to discuss about stream and the block ciphers, right? First one, let us move with our session, outline. So before entering with the outline also, we should understand why we are discussing all this information now, right? As we are about to enter into the mainstream of cryptography, that is a standard algorithms, we should understand the basic versions of how we have designed this kind of algorithm. So like what is the initial stage of designing these algorithms? So this outline will give you a proper structure how these standardized algorithms are about to be in future, right? So the outline is divided into 7. So these 7 are nothing but the first stream and the block ciphers. Next, we are going to discuss about the block cipher design principles and the ideal model of that, and how these block ciphers are designing with respect to the product cipher, that is SP network. So from SP network, how we are going with the confusion and diffusion, and at last the peaceful cipher structure with its design elements. So let us start with our session of the stream cipher. See, stream cipher is nothing but we are going to encrypt our data byte by byte or bit by bit at a time. So this is the first and foremost type of streaming, classical streaming cipher, where we are going to add an XOR operation. See, if you have this basic example, if you can see here, the key size and the plain text size will be always same in the stream cipher. Let me give you an example. If my key is 1001 and if my plain text is 1100, right? So I'll do XOR operation with this 1100. Now I'll be getting, when I apply with the XOR operation, my truth table will be, if both are same, the result is 0. Remaining all are 1. Both are same means 0, right? So my output over here is 010. So which is called as a ciphertext. I will be forwarding to the receiver end. Now my receiver is ready with 0101 as a ciphertext. Now what is the key stream? So this is a key stream which I took, right? So this is the key I'm going to apply here. So when I apply again XOR operations, same means 0, right? So I'll be getting 1 here. So this is my plain text which is matching with the input plain text from the sender, right? So this is the format of applying bit by bit ciphering and or byte by byte ciphering. So this is the concept of stream ciphers, right? So let us move with the next type of the cipher, that is a block cipher. See, block cipher is very simple, that instead of going with a bit by bit, byte by byte and increasing the complexity every time, and as we have plain text, let me say my plain text is of 612 MB data, and 612 MB data is divided into n number of bits, where my key size also to be as the same as the 612 MB bits of 612 MB converted into bits format. So that many bits I need as a key also. So for that, what we are doing is we are converting our data into blocks. So if my plain text is of 512 bits of data, 512 bits of data. So I will be converting this into equal sized blocks. Let me go with 64, 64, 64 equal sized bits of data. So here, if I go with 64 bits, I need into 8. right? 8 into 64 bit sized blocks I want. So 512 bits will be converted into 8 individual blocks of 64, 64, 64 each, right? So all these 64 blocks will be considered as equal size blocks where I am going to apply encryption on the overall block with some key K. Okay. And next key is K. Next block, next K, next block, next. So when I have n number of bits like this, I'll be converting into equal sized blocks called as block size either 64 or 128 bits, right? So this will be always equal in length. Now, when I'm applying encryption algorithm, I'll be applying with the equal sized key length also. So this is about the block ciphers. So block cipher principles are, see, in the block cipher principle, we should understand only one point, that we should follow a Feastal cipher. So Feastal cipher is nothing but which will be having a number of rounds which will be repeatedly applying same functions. Okay, so this is nothing but the Feastal cipher. In this Feastal cipher, I must decide as a developer of an algorithm, we must decide how many bit I should go with one block. Either it is 64 bit or 128 bit or 512, 256. So like this, we should be deciding with the n number of bits first for every block. Now, my Feastal cipher should be ready with n number of rounds, right? So every round will be having the idea of the product cipher. So what is product cipher? As we know in the previous session, substitution, apply substitution and transposition whenever required. So transposition is nothing but applying n number of permutations. So transposition cipher and permutation cipher both are same. So in exam point of view, if you get 2 marks question, write short notes on permutation cipher, you should not be get confused. You should be immediately getting one idea that this is nothing but the transposition cipher. Got this? Now, so block cipher principles are this, that we should have the block size, we should have the idea of the product cipher, we should have the Feastal structure, right? Next. So as we are moving in depth, why we are doing all this? To provide secrecy and authentications to all the services. Now, what is the ideal block cipher we have? If we take equal sized input, then equal sized output should be there. See, here we took input of 4-bit. Immediately we must have output of 4-bit for sure. In bit, whatever you are applying is a secondary thing. That is the either substitution, transposition, that depends on the algorithm idea, right? So whatever you take, the ideal thing which you must follow is how much is the input size, that much should be the output size. In between, whatever you are applying will be the secondary thing, right? So next part is about, it's about the SP network. So SP network, see, from the beginning, we are saying the product cipher. The main theme of product cipher is itself the combination of substitution and permutation. So we call this substitution permutation as the SP networks in the cryptography terminology. So when we say SP network, immediately you should understand that we are going to apply the product cipher. Okay. So in the modern algorithms, we have included the classical, the traditional things, that is substitution and transposition, and we are calling in a modern way as a product cipher. That's it. See, everywhere foundations are very important, right? If we are into the post-graduation, means we have done with the elementary. In the same way, if we are into the product cipher, we are with the traditional things also, right? No. So here we have two primitive cryptographic operations we are going to perform. That is substitution and the permutation. Substitution terminology is the S box. Permutation terminology is the P box. So with the use of these two, we are going to provide two terms, that is confusion and the diffusion. See, where diffusion is a concept which will be disappearing the main plain text idea to the hackers. Disappearing the main plain text idea to the hacker. See how we are saying this? Diffusion will dissipate, means disappears. Statistical structure of plain text over bulk of ciphertext. See, after saying the ciphertext also, we may get some ideas as if I am an adversary or attacker or hacker, intruder, the bad guy, whoever we call all these terms, will be in statistical structure, thinking about the mathematical structure of your ciphertext which we have in our hands. So if I see the ciphertext, I should not get any idea of the plain text. That is the main aim of providing the standardized algorithms using product ciphers. So we should disappear the hints of the plain text. Okay. So this is the first point. So coming to the second point, that is a confusion. So confusion is a theme where we should be having a complex relationship between the ciphertext and the key. See, after having the ciphertext also, it should make the attacker to find what key we might have utilized. Okay, that complex it should be there. So diffusion and confusion are the main services or the main ideas provided by the product ciphers, right? Now, Feaster structure. See, coming to the Feaster structure, it is nothing but SP network concept. So, what is SP network? Just we have discussed substitution, permutation. Now, when we are applying SP network as an encryption, we must have decryption process also for this, right? So, invertible decryption process. We call the reverse of this as a invertible at the decryption side. Now, when we have our content, plain text in our hand, first divide into two types in the Feaster structure. Two halves. See, I have A, so divide into two. Next, left part, right part. So apply whenever required, perform substitution on the left data. Next, right data should be applied with the round function. See, right data should be applied with the round function. This must be applied with the substitutions. See, all this we are going to see in detail with the examples where key is also applied with this, right? Now, after getting all this, you must go with the permutation. So here we have substitution, some functions, some key, and the permutations, right? So let me give you one diagrammatical representation of the Feaster structure. See, left part is given with the round functions with the key. Round functions with the key. See, left part is given with the round functions with the key, where right part is given as a left part directly. Okay. So this is a concept we are going to repeat for n number of rounds. If I have 10 rounds, I'll be repeating for the 10 rounds, right? So finally, the Feaster cipher design elements will be this. We must have the block size, key size, number of rounds we are about to perform. Next, we must have the key generation thing, round functions. See, number of rounds and every function what we have to do. Now, the concept of the exact algorithm and analysis. See, if we are doing this, what may happening? If we are applying this, are we safe or not? So everything we should analyze, right? So this is the final Feaster structure encryption and decryption process, which we are about to discuss in the DES algorithm in the next session, right? So I hope everyone is clear with the session today. If you have any doubts, be free to contact anytime through the comments or else any media which we have in the college. Thank you.